In this lecture, we're going to learn how to balance equations. Now, we've already figured out what is meant by a coefficient and what is meant by a subscript in an equation. Before the basic idea of balancing equations is that you cannot create or destroy atoms. So atoms cannot be created, nor can they be destroyed, except in nuclear reactions. We're not dealing with nuclear reactions, we're dealing with everyday reactions. So you cannot create or destroy atoms. And the amount of atoms, now based on that, the amount of atoms in your reactants and the amount of atoms in your products, that must be equal, because atoms cannot go missing somewhere. If you're doing a reaction, the end product must contain the same number of atoms as the amount of atoms in your reactants. So let's start off with the basic equation. I'm going to take hydrogen, and I'm going to react it with oxygen, O2, and they're going to produce H2O. So hydrogen reacts with oxygen and produces H2O. Remember one thing, that the formula of hydrogen is a diatomic molecule, so the formula of hydrogen is always going to remain H2. You cannot change the formula of hydrogen in any way. That's impossible to change. So this here is a molecule of H2, and what this small 2, this subscript, denotes is that there are two hydrogen atoms. Because it's 2, that means there are two hydrogen atoms joined together. Similarly, this oxygen molecule has this formula O2, in which two oxygen atoms, and they have a double bond in between, so the two oxygen atoms joined together. You can't change the formula of O2 as well. And finally, your product is H2O, and H2O states 2 is the subscript. That means that there's one oxygen atom and it's joined with two hydrogen atoms, and they're all joined together. And you can't change the formula of H2O as well. You can't change the number of bonds. So these are the formulas of the compounds, and you can't change the formula. That's the first thing. The only thing that you could change is the number of molecules that you have. So for example, if you look at the balancing side, you have a total of two hydrogen atoms over here, and I'm just counting the hydrogen atoms. So that you have two hydrogen atoms and you have two oxygen atoms, but on the right hand side in your products you only have one oxygen atom and you have two hydrogen atoms. Ignore the subscript in the last thing that I wrote. That doesn't mean anything. I'm just counting atoms. So there are two hydrogen atoms and the two oxygen atoms on your left hand side in your reactants, and there's one oxygen atom and the two hydrogen atoms in your products. Now the first thing that needs to be corrected is this fact over here. There's only one oxygen atom, so I need to increase the number of oxygen atom, but I cannot change the formula of water. So the only way I can change the amount of oxygen atoms is by having another water molecule. So if I have another water molecule, now I have another oxygen atom and I have two more hydrogen atoms. So now the total amount of oxygen is correct. I have two oxygens on my left hand side and I have two oxygens on my right hand side. The only difference now is that there are four hydrogens over here. So I need to change the number of hydrogen atoms. What I can do is I can have one molecule, another molecule of H2. So if I have another molecule of H2, I get two more hydrogens. Now if I look at the number of atoms on my left hand side and the number of atoms on my right hand side, now they're equal. There are two oxygen atoms over here, there are four hydrogen atoms. On the left hand side there are four hydrogen atoms and there are two oxygen atoms. Now the balancing is correct. So I needed, and now I'm going to balance this equation. So in total I needed one molecule of H2 and another molecule of H2. So I need two separate molecules of H2. So that would be my coefficient. I just need one molecule of O2, so that's fine. You don't need to write 1. And I needed two molecules of H2O, two separate molecules of H2O. So 2 would be my coefficient. Now this equation is perfectly balanced. In this example, I'm going to try and balance H2 reacting with I2 and it's producing HI, and I'm going to try and balance this equation. Now again, H2, the small subscript 2 denotes that in one molecule is there are two hydrogen atoms bonded to each other. So they're joined together. I2, the small subscript 2 denotes that in one molecule there are two iodine atoms joined together, and HI states HI is the product that is formed. So in one molecule there's only one H and one I, and they are bonded together. Now remember, you cannot change the formula. The only thing that you could do to balance the equation is to increase the number of molecules. So if you count the number of atoms on the left hand side, there are two hydrogen atoms on the left hand side, your reactant side. So you have two hydrogen atoms, and over here you have two iodine atoms. So that's the number of atoms on your left hand side, two hydrogen atoms and two iodine atoms. Whereas on the left hand side there's only one hydrogen atom. On the right hand side, in the product side, you only have one hydrogen atom and you have one iodine atom. So the equation is not balanced. I need to increase the number of hydrogen atoms and number of iodine atoms on my right hand side or my product side. There should be more than that. So what I can do is I can have another molecule of HI. So if I have another molecule of HI, another separate molecule of HI, now I'm going to have one more hydrogen atom and I'm going to have one more iodine atom. Now if you look at the total number of hydrogen and iodine atoms on the right hand side, there are two hydrogen atoms and there are two iodine atoms, and on the left hand side there are two hydrogen atoms and two iodine atoms. Now the equation looks perfectly balanced, and I need to simply add that to the equation. So there's going to be only one H2 molecule, there's only going to be one I2 molecule, but there are going to be two molecules of HI, and this would be my coefficient. 2 states that there would be two separate molecules of HI. So this over here is my balanced equation. One molecule of H2 is going to react with one molecule of I2, and it's going to produce two molecules of HI. In this example, we have one molecule of CH4 and it's combusting with oxygen and it's producing carbon dioxide and H2O. So the equation is written and the formulas are given, and we need to balance the equation. So what CH4 means, the small subscript 4 means, is that there's one carbon. So there's one carbon and it's bonded to 4 hydrogen atoms. So there's one carbon, there are 4 hydrogen atoms, they are all joined together. Then you have an O2 molecule, that means there are 2 oxygen atoms and they are joined together. Then you have a carbon dioxide molecule in which you have one C and 2 oxygen atoms and they are joined together. So these are the structures of these molecules. And H2O, that means there are 2 hydrogens and 1 oxygen joined together. So H2O would look something like this. Now I'm going to count the number of atoms in my reactants and in my products. So over here I have on the left hand side I have one carbon atom and I have 4 hydrogen atoms. O2 is my other reactant, so there are two oxygen atoms. Then you have carbon dioxide in your product, so you have one carbon and you have 2 oxygen atoms. And H2O is your other product, so that has 2 hydrogens and it has 1 oxygen atoms. Now if you look at this entire equation, the first thing that you'll notice is that there are 4 hydrogens on one side. So the first thing that you'll notice is that there are 4 hydrogens in your reactants, but there are only 2 hydrogens in your products. So you need to double the amount of hydrogen in your products, and you can't change the formula. So the only thing that you could do is that you can have another water molecule. So if you have another water molecule, so that would double the amount of hydrogens that you have in your product. So if you have another water molecule, you'll have 2 more hydrogens and you'll have 1 more oxygen atom. So in your products, the total amount of carbon is there's 1 carbon. There are 2 oxygens over here and there are 2 oxygens on the other side. So you have a total of 4 oxygen atoms and you have a total of 4 hydrogen atoms. So that's the total amount of elements or atoms of elements in your products. And now if you look and compare, there's one carbon in your, there's one carbon. So let me, these are my reactants. So I have one carbon, that's balanced. There's one carbon in the product. I have 4 hydrogen, that's also balanced. But I only have 2 oxygen, so I need to somehow increase the number of oxygen atoms, and I can't change the formula, so I need to increase the number of oxygen atoms because there are 4 oxygens on this side. So there should be 4 oxygens on the in your reactants as well. So the only thing that I can do is I can increase the number of molecules of O2. So if I have 2 oxygen molecules, that would increase the amount of oxygen atoms. That would add 2 more oxygen atoms in my reactant. So I would have a total of 4 oxygen atoms, and now the equation looks perfectly balanced. So the only thing I need to do is I need to add this in my equation. So I have 1 CH4 molecules, I have 2 molecules of O2 denoted by this coefficient because they're 2 separate molecules of O2. I have 1 molecule of CO2 and I have 2 separate molecules of H2O. So the coefficient of H2 is going to be 2. And that's my balanced equation. We will now start doing some practice problems on balancing equations. I'm going to try and balance the equations without going into a lot of detail. So let's start with this first equation. N2 plus H2 gives you 2NH3. Now if you look at the reactants, you have 2 nitrogens. And if you look at the product, you have just 1 nitrogen. So you need another molecule of NH3. So if you have 2 molecules of NH3, that would give you 2 nitrogens. But 1 molecule of NH3 has 3 hydrogens, so 2 molecules of NH3 is going to have a total of 6 hydrogens. So now your product is going to contain 6 hydrogens, and your reactant should also have 6 hydrogens. So what you can do is you can have 3 molecules of H2. That would give you 6 hydrogens because 1 molecule has 2 hydrogens and 3 molecules are going to have a total of 6 hydrogens. So if you count the atoms now, there are 2 nitrogens on the left hand side. There are a total of 6 hydrogens on your reactant side, and in your product side you have 2 molecules of NH3. That means you have 2 nitrogens, and 1 molecule has 3 hydrogens, so 2 molecules is going to have a total of 6 hydrogens. So you have 6 hydrogens in your product as well. So now the equation is perfectly balanced. Let's try and balance the second equation where you have a sulfur molecule, and in 1 sulfur molecule there are 8 sulfur atoms joined together, and you have an O2 molecule in your reactants, and they are reacting and they're producing 1 molecule of SO2. Now if you look at your reactants, there are 8 sulfur atoms, so there should be a total of 8 sulfurs, and you cannot change the formula of the product. Sulfur dioxide is SO2. So the only way you can have 8 sulfurs is if you have 8 separate molecules of SO2. And that would give you a total of 8 sulfur atoms. So you have 8 sulfur atoms in your products, and you have 8 sulfur atoms in your reactants as well. The other thing that you need to balance is that if you in 1 molecule of SO2 you have a total of 2 oxygen atoms. So if in 8 molecules you're going to have a total of 16 oxygen atoms. So there should be 16 oxygen atoms over here, but in 1 molecule of O2 there are only 2 atoms of oxygen. So you need a total of 8 molecules of O2, and that would be equal to 16 oxygen atoms. So now your left hand side and your right hand side, your products and your reactants have the same number of atoms. In this third example, I have 1 molecule of N2. 1 molecule of N2 contains nitrogen, contains 2 nitrogen atoms joined together, and I have 1 molecule of O2. That means that 2 oxygen atoms joined together, and they're forming a molecule of N2O, which means that in 1 molecule you have 2 nitrogen and 1 oxygen atom. Now I need to balance the equation. So the first thing I notice that is unbalanced is that there are 2 oxygens over here in my reactants, 2 oxygen atoms in 1 molecule. So there should be 2 oxygen atoms, but I cannot change the formula of N2O. So the only way I can have 2 oxygen atoms is if I have a total of 2 molecules of N2O. And since this is a coefficient, that means there are 2 separate molecules of N2O, but that would give me 2 oxygen atoms in my products. And if I have two molecules of, that means that I have two molecules of oxygen, but in one molecule there are two nitrogens. So in two molecules there are going to be a total of four nitrogens. Now my oxygen is balanced. There are two oxygens in my products, but my nitrogen is unbalanced because I need four nitrogens over here. I cannot change the formula, so the only thing I could do is I can have another molecule of N2. If I have two molecules of N2, that would give me a total of four nitrogen atoms. Now my left hand side, my reactants and my products, they're all balanced. In my reactant side I have four nitrogen atoms and I have two oxygen atoms. In my products I have two oxygen atoms and I have four nitrogen. Now the equation is completely balanced. In this fourth example, I have an equation where a phosphorus molecule is reacting with an oxygen molecule and it's producing a molecule of P2O5. So that's the formula of the molecules. Now if you look at the equation, in one molecule of phosphorus there are four phosphorus atoms joined together, but in one molecule of P2O5 there are only two phosphoruses. So I need to balance this. The only way I can increase, there are four phosphoruses over here in one molecule. So the only way I can increase the number of phosphorus over here to 4 is by having another molecule of P2O5. So if I have two molecules of P2O5 and I'm writing that as a coefficient, if I have two separate molecules of P2O5, that would give me a total of four phosphorus atoms in my product. So now the phosphorus atoms or the element of phosphorus is balanced. But in one molecule of P2O5 there are a total of 5 oxygens. So in two molecules there would be a total of 10 oxygen atoms. Now I have 10 oxygen atoms in my products. I need to have a total of 10 oxygen atoms, but in one molecule of O2 there are only 2 oxygen atoms. So I need 5 molecules of O2. Without changing the formula, I would need 5 molecules of O2 to have exactly 10 oxygen atoms. And now my left hand side and my right hand side, my reactants and products have the same number of atoms. In this example, I'm going to deal with slightly tricky equations which are harder to balance. Now, if you look at this entire equation, there's one Na on the left hand side and there's one Na on the right hand side. So sodiums are balanced. There's one oxygen and there's one oxygen on the right hand side. That's also balanced. But the problem comes with hydrogen, because in my reactants I have, if you look at H2O, I have 2 hydrogen atoms. But in my products, I have 2 hydrogen atoms over here in this molecule of H2, and I have another hydrogen atom in NaOH, which is my other product. So I have a total of 3 hydrogen atoms. So I need to increase the number of hydrogen atoms in my reactants, but that would create a problem, and that problem is that I can't change the formula. And since I cannot change the formula of H2O, what I can do is I can have another H2O molecule. So if I have 2 molecules of H2O, that would give me 2 more hydrogens, but that would make the total number of hydrogens in my reactants to 4. It would take that to 4. That is going to be greater than the 3 hydrogen atoms that are in my product. So I need to increase the amount of hydrogen in my products, and the way I can do that is I can either increase the number of molecules of H2, but if I do that, that will not solve the problem, because if I have 2 molecules of H2, that would become 4 hydrogens, and add 1 to it, that would become 5 hydrogens. So if I should increase, because I only need 1 hydrogen, so I can have another molecule of NaOH, and remember, I cannot change the formula. The formula of NaOH stays the same. So if I have another molecule of NaOH, now this has 1 hydrogen atom. So if you have 2 separate molecules of NaOH, that would give you another hydrogen atom, and that would take the number to 2 hydrogens. So that would take the number to 2 hydrogens. So this here is going to give me 2 hydrogen atoms, and in one molecule of H2, that's also 2 hydrogen atoms. Now if I compare my reactants and my products, I have 4 hydrogen atoms on both sides, but this disturbs the balancing. The hydrogen is balanced now. The oxygens are balanced as well, because one molecule of H2O had 1 oxygen atom. 2 molecules of H2O are going to have 2 oxygen atoms. One molecule of NaOH has 1 oxygen atom, and 2 molecules of NaOH are going to have two oxygen atoms. So oxygen is also balanced on both sides. I have two oxygen atoms. The only thing that is unbalanced now is sodium. Sodium in one molecule of NaOH, there are two sodium atoms. So you have two sodium atoms in your products, but you just have one sodium atom in your reactant. So this should be two. So I would have two sodium atoms in my reactants. And now the equation looks perfectly balanced because all the elements are balanced. The oxygens, the sodiums, the hydrogens, they're all balanced now. Now this one is a slightly more difficult equation to balance, but we're going to start in exactly the same way. You have a total of 7 carbons in this one molecule of C7H16. So that's one molecule. So there's 7 carbons over here. And my product should also have 7 carbons, but this carbon dioxide molecule only has 1. So there should be a total of 7 molecules of carbon dioxide. So if you have 7 molecules of carbon dioxide, that would give you a total of 7 carbon atoms. So my carbons are balanced now. Now I'm going to move to hydrogens. There are 16 hydrogens over here. So over here I have just 2 hydrogens over here in this molecule, in H2O. So I need to somehow increase that number to 16 hydrogens, and the only way I can do that is if I have 8 H2O molecules, and in one molecule there are 2 hydrogen atoms. So in 8 molecules there are going to be a total of 16 hydrogen atoms. So my carbons and my hydrogens are now balanced. There's 16 hydrogens on the left hand side in my reactants, and there's 16 hydrogens in my products. Now the last thing I need to do is I need to calculate the total amount of oxygen. They should be equal on both sides. So over here in one molecule you have 2 oxygen atoms. So in 7 molecules of carbon dioxide you're going to have 14 oxygen atoms. Over here in one molecule you just have 1 oxygen atom. So in 8 molecules you're going to have a total of 8 oxygen atoms. So if you total that, that's going to give you 22 oxygen molecules, and I should have 22 oxygen atoms, and I should have 22 oxygen atoms in my reactants, and one molecule of O2 has 2 oxygen atoms. So I need to have a total of 11 molecules of O2. So if I have 11 molecules of O2, that would give me, since each molecule has 2 oxygen atoms, so 11 molecules of O2 is going to give me 22 oxygen atoms. Now if you look at the reactants and the products, the total number of atoms of different elements is exactly the same in the reactants and the products.